Hi, my name is Praveen. So I like to explain about the biodiesel. First of all, biodiesel is an alternative to conventional diesel fuel is produced from the sustainability harvested biological materials, including oils from example vegetable oils and animal fats. Biodiesel also an environmental advantage since it degrades naturally, non-toxic and has a lowest emission rate. Besides with the development of the affordable petroleum and suitable crude oil fraction and a refined for the usage of the fuel, leading to the co-evolution of a diesel fuel and a diesel machine and engines. Following this further, biodiesel known as an alternative fuel that offer various advantages. Its production reduces the reliance on imported petroleum fuel that is used in native and renewable resources. Besides, it also decomposes naturally and it be classified as a non-toxic. It also need a less emission of a CO known as a carbon monoxide, especially in a matter along with the untested hydrocarbon and a petroleum related diesel and a biodiesel as a superior combustion emission. For the trans-esterification, alcoholysis is the trans-esterification process that occurs when the initial ester react with an alcohol. In keeping with the majority of papers in this topic, the term of trans-esterification will be used to refer to the alcoholysis of the carbolic ester in the study. Since the trans-esterification is an equilibrium reaction, the reactants are effectively mixed to the effect of transformation. The introduction of a catalyst, often a strongest acid or basic that speed up the adjustment of the equilibrium and albeit along with the sustainability. Alcohol must be used in excess a big yield of ester to be obtained. Trans-esterification sometimes is called as alcoholysis, which is the process that perform a non-eligible oil to chemically react with the chemicals such as alcohol. Related to the chemicals such as methanol and ethanol are most used in the procedure and steps since they are affordable and widely free or available. Moreover, the viscosity of a non-irritable oil can be low by usage of the technique that to cover the triglyceride into the ester.
Next is methodology, and for this experiment, these are the calculation for material preparation, which to determine our weight of catalyst and methanol. And for methanol, we use calculation of molar ratio, using molar ratio, and then for catalyst, we use percentage from the mass of cooking oil. For our experiment, these are the parameter that we use. The first one is using 200 milliliter of waste cooking oil, and the second one is using 100 milliliter of waste cooking oil. Our molar ratio we keep as constant, which is 18:1. And then for catalyst concentration, the first experiment we use 3%, and the second experiment we use 5%. And this is the procedure of our experiment. First is preparing the material, and then second one is heating the waste cooking oil to eliminate water, which also this picture describe the trans-esterification process. And our reaction time is 1 hour, and then we wait 24 hours for separation process, and then after that we filter the biodiesel that has formed, and then we go to washing. And for washing, we use pH paper to determine the pH value of our biodiesel, to determine how many times we have to wash it. And then after that, we heat once again the biodiesel to eliminate water. And the last one is acid test to determine the acid value.
So for our result and discussion, in this project, we carry out two set of experiment. The result that we had obtained for experiment is 3% for yield and weight of biodiesel produced is 47.598 gram. And then for experiment 2, we got 5% for yield and 38.865 gram for weight of biodiesel produced. In our discussion, stated that the mixture was effectively separated into three layers: methanol on top, biodiesel, used cooking oils, fat in the middle, and water on the bottom. Impurities were removed by filtration and multiple washing with heated water. At 110 degrees Celsius, extra water was removed from the produced biodiesel. The acid value analysis revealed that 0.5 ml of KOH was necessary to attain a pink color change. Using a homogeneous catalyst, the experiment produced biodiesel at rate of 23.81%, which is 100 ml cooking oil and 5% catalyst, and 38.87%, which is 200 ml cooking oil and 33% catalyst. This result demonstrates the potential of heating oil biodiesel production at temperatures between 65 degrees Celsius and 70 degrees Celsius.
Assalamualaikum. My name is Muhammad Afishafi bin Muhammad Fazli. My matric number is B0920101772. So today I'm going to explain the factors that affect the production cost yield of biodiesel. Okay, the first one is the availability of waste cooking oil can vary depending on the region and source. The second one is the choice of catalyst used in the esterification process can affect both the cost and the yield of biodiesel production. The third is the reaction temperature. Reaction time and molar ratio of oil to alcohol are essential parameters that impact both the yield and production costs. The fourth one is the choice of purification technique, such as washing and drying, can influence the yield and production costs. And lastly, the utilization of byproducts such as glycerin can offset the production costs. That's all for me.
Okay, so the problem we encountered during the process if we didn't manage to handle the drying process. The reason of the burning oil is because of we can handle the temperature when the drying process. This is because we use an old design of hot plate that needs pliers to adjust the temperature. So we can see from the figure that is the burning oil that we get when the drying process. So the effect of that, the temperature increase up to 240 Celsius and the color also changed to black as shown in the figure. It also emits a burning smell. So how to prevent it from happen? So we must control the temperature wisely or use a new type of hot plate that equipped with temperature sensor.
Hi, my name is Muhammad Nasrul Aiman bin Muhammad Zulkarnain, and my matrix number is B0920102221. And right now I'm going to explain about the conclusion that we have been received, that we can be conclude from the experiment. As you can see, we were able to achieve the objectives of the experiment successfully, which is to produce waste cooking oil from homogeneous catalyst and to evaluate the effects of impotence, such as molar ratio of oil to methanol catalyst concentration, reaction temperature, and reaction time on the yield production. Experiment's objectives were accomplished successfully. Waste cooking oil turned into biodiesel. With 5% of catalyst and molar ratio of 18 to 1, we were able to convert used cooking oil into biodiesel. Moreover, new knowledge gained regarding the procedure for refining used cooking oil into biodiesel. By conducting the experiments, additional knowledge on the environmental advantages of biodiesel production was gained. The fact that biodiesel generates fewer emissions than fuels derived from petroleum serve as evidence of the benefits biodiesel production has on the environment. That's all from me. Thank you.